sir has not joined, so I will be taking over. And my topic, which I was about to speak, was on practical aspect of basic biostatics, because biostatics is one of the most important area where medical researcher and medical fields are. We don't have much in-depth knowledge. I mean, basic knowledge is there, but in-depth knowledge is not there. So I will be speaking a little bit about biostatics, but since the theoretical basis of biostatics has been taken over so frequently and so many times, so I will be focusing only on the practical aspect, that is using SPSS, as my title says so. So let me check my slide. So I request everyone who are familiar with the working of the SPSS, for them this will be useful. For those who doesn't know how to do and the basic stuff of SPSS, then we will be organizing, or we want to organize in the near future, entire workshop on biostatics and practical aspect of biostatics by using Excel, by using SPSS, by using Graph Prism. So these are the basic software, as well as the reference managing software also, like Mendeley and Not, all this stuff, which are very much important for any type of researcher from any field. So we will request all the participants to give their viewpoint, so that we may be able to organize accordingly in the near future. Okay, so I will be taking over. And I am Dr. Hanjabam Barun Sharma, IMS BHU, and I will be speaking about practical basic statistics, which is essential for biomedical research, and this will be done entirely using SPSS. So before going on to SPSS, we will try to, some basic about statistics. This thing we have already explained. Various eminent speaker has already explained what are the different steps of the research proposal, and what type of the paper, your paper should constitute, what are the different points. So the one which we are going to focus is at the analysis of the result. That is, you collected the data, and then after collection of the data, you apply, you analyze the data so that some result is obtained, and based on the result, you can go forward for writing, for the discussion, and hence preparing for your manuscript. So this was a recent paper which was published. This is a checklist for statistical assessment for medical papers, the CAM statement. So here you can see that there are so many points. The checklist is being done, so that basically you have to see from every point, like clear description of the goal of research was done, or yes or no. So all these are the key points which one must be kept in mind. So this is easily available. One can search, and it was published in I think BJSM, British Journal of Sports Medicine or something. Yeah. So we all know the teaching, how teaching of biostatics is there. It is very simple, straightforward, and all the basic points are there. But the problem comes when you do statics. Doing statics is a very, very practical aspect. So many a times it's not written in a book how to go about and how to do it. So I will be focusing on doing biostatics here. And doing biostatics was, in earlier days, it was difficult because everything has to be done manually. But the good thing is nowadays different software are there, like Excel is there, SPSS is there, and people are using R software, Stata, and all this stuff. So basically what is important is because of the availability of the different software, it becomes relatively easier. So before going, not going into the very detailed theoretical basis, very, very few basic point, theoretical basic point, which one has to remember is type of the hypothesis and this one, that is the type 1 error and type 2 error. Everyone knows that. So I am not going to focus. What people doesn't, basically understand is nowadays the too much emphasis on a p-value, because people are so much, fixed with this idea that p-value has to be less than 0.05, then only and only my result is good, like that. So this is not a concept. So nowadays, instead of giving significant or non-significant, the reviewer and the most reputed journal, they are asking a p-value. One should write the p-value up to at least 3 decimal point, and one should always give the confidence interval. Confidence interval is very, very important. It is more important than compared to the p-value itself. That is that one has to know. And also many a times the people are just giving the SEM, that is systemic, instead of the standard deviation. So the people are, because SEM is basically standard divided by root over n. So since this is a very lesser in numerical value as compared to the standard deviation, people often give that value, which is basically not right technically. So I want to say that if you write a paper, if you submit a paper, 2-3 points which you have to remember. Number one, you have to write p-value, exact value, not significant, not because significant and everything is what you fix. 0.05 is what you fix. 0.05 as an alpha value is what you fix. So what is important is you have to write the numerical value of p-value at least up to 3 decimal point. If you can write 5 point, it's also right. And another point is you have to write the confidence level. Very much important confidence interval you have to provide. And another key important is you have to write the measure of effect size. Effect size is absolutely very important in case of medical reasoning. So there is something known as statistical significance, and there is another one is also known as medical significance. So all this point which you have to write, and another one which I want to, I usually write in my paper is you have to write the, the range also, minimum to maximum if it is there. So instead of just writing mean plus minus standard deviation or mean plus minus SEM, it's always better to write the, the effect size, the exact p-value, the confidence interval. So our focus should be less on the exact value of p-value. Instead, it should be more focused on confidence interval. So this is important. Confidence interval is nothing but 1 minus alpha. 1 minus alpha error, it is a confidence interval. Another is the 1 minus, that is beta, which we have no. That is what, that is power of a study. So I am not going into all these theoretical details because I will be straightly going into the software. So before doing any kind of test, 3 things is very important: the sample size, and normality, and homogeneity of variance. Sample size. See, sample size we have already seen in the paper which was submitted by Dr. Sushil. There was we are able to see that difference was there, but not statistically. Why? This is because of the sample size. Statistically significant difference. If the difference is very small, still you are able to statistically the difference is there, then it can only happen when your sample size is very, very large. Okay, if the sample size is very less, like 5 or 6 mice, this is usually happen in case of the animal study, because the focus of the animal study is reduce the number of the animal as much as possible. This is the number 1 criteria for any kind of animal ethics. So because of this criteria in animal study, we are facing with the lots of problem because of the smaller sample size when applying for different statistically tests. So sample size criteria is very important. By central limit theorem, which we already learned in a basic biostatistics class, is it should be more than 30 or 40. But 30 or 40 is not the criteria which one should remember. Instead of the 30 and 40, what is important is the larger samples. The more larger, the better it is. The better for what? Better for detecting any kind of difference. And another is the normality, because many of the tests which we have to apply has a basic assumption. There are certain assumptions for different type of tests. For that, normality testing is there. But unfortunately, many of the authors, they don't do any kind of the normality testing. What they do is they just apply t-test. They just apply whatever test they want, which are parametric tests, instead of doing any normality. Another one is very important but highly neglected is the homogeneity of the variance. It is also known as homoscedasticity. And this homoscedasticity or homogeneity of the variance, there are certain tests are also there, but usually they are not done. But one must know that in even in non-parametric tests also, there are certain non-parametric tests where Wilcoxon sign rank test, where homogeneity of variance is extremely important. Assumption is there. You cannot violate that assumption. Still, people doesn't do. But that's why I am here to talk a little bit about them. So going to the next slide. What is happening? Yeah. So let's go to the basic about how does the our distribution look like. That is normality. the two key important points which I want to say: skewness and kurtosis. Skewness, the shape; kurtosis, how pointiness or how flat is the graph. And what is the practical point? The practical point is the kurtosis. If you analyze by using SPSS or any kind of software, some numerical value is there, and for a kurtosis, for a normal kurtosis, it is generally 3, approximately around 3. If the numerical is more than 3, then it is a leptokurtic, and and it is less, then that is a platykurtic. So the most important is if the numerical value of kurtosis should be approximately around 3. Another one which is important is the skewness. The skewness, which is number. For a normal skew, normal skew, approximately it should be between -half to +half. It should be between that. Then only we can say that this is approximately normally distributed as far as skewness is concerned. If it is more than this one, if skew less than -1 or greater than, then it is said to be highly skewed. So many of the, why this is important? This is important because many of the statistical tests required assumption for normality. Another one is the homoscedasticity, which I have explained. That is the homogeneity of the variance. If you are going to compare with different groups and each group has a different variance. What is variance? Variance is nothing but the what? Square of the standard deviation. That is the variance. And standard deviation, variance, interquartile range, quartile deviation, these are the measure of dispersion. How far the point is dispersed from the central value, that is mean, median, mode. So these are the basic class. I am not talking about basic class here, but I would like to take suggestion of all the participants. If you want a kind of class starting from the very basic, we can also do it. For that, we will plan, depending upon your feedback, we can plan a workshop or something like that. So homogeneity of variance, rule of thumb. There is one rule of thumb. If you don't have any kind of test, you don't know how to apply it, there is one rule of thumb. If you have multiple groups, then the larger variance divided by small variance, it should be less than 3. Ideally, if it is less than 1.5, then it is very, very good. Otherwise, if it is less than 3, then you can approximately assume that homogeneity of the variance is there, and you can go ahead with a different test which you are assuming. Another one is the outlier. Outlier is the one which is, whether you have to remove it, whether you don't have to remove it. There is a controversy is there, because if you remove the outlier, then what will happen? Your sample size will reduce, and your sample size directly detect the power of your study. So the power of your study will be reduced. Another one is by reducing this outlier, then you may create a bias also in your study. The result may be biased. So there is one group of researchers, one group of authors, statisticians, they are saying that don't remove the outlier, be it like that. Another group says that just remove the outlier, because if you remove the outliers, then the whole data may be approximately normally distributed. Earlier it was not, then it may become normally distributed also. So all these things which you have to remember, and for that you have to know what is the outlier leveling rule. How much you can say the outlier. The most important leveling rule is 1.5. If it is more than 1.5, that is interquartile range, IQR, then we say that a particular value is an outlier. Here, this is a box Whisker plot. You can see this is the box plot, which everyone must be knowing. This is the median. This is the upper quartile, that is 25%, lower quartile, this is 25%. So it should be 25, 50, and 75. 75 will be here, and this is the maximum value. So the one which is from this end, upper end of the Whisker box plot, from here up to this end, this one, up to this one. And if this is, and from here to here, the difference between 75 percentile and 25 percentile, it is known as interquartile range, IQR. And if you divide interquartile range by 2, it becomes quartile deviation. So quartile deviation is we generally use for those data which are not normally distributed. Instead of using standard deviation, we use interquartile range. So if your value is lying outside 3/2, or the most important point is 1/5, from here to here, if you minus 75 minus, that is 25, it becomes your interquartile range. And upper value may, if your value is higher than 1.5 times of interquartile range, then you can say that a particular value is a outlier. Then this was the first technique which was introduced. But there is one problem. 50% of the data which are labeled as an outlier by using this 1.5 rule are not an outlier at all. Why? Because see, this is a normal distribution. Everyone must be knowing this. This is a normal distribution curve. See, normal, this is a standard deviation. 0, this is a normal distribution bell-shaped curve, and this is a plus 1 standard deviation, plus 2 standard deviation. So if you are assuming that whole your data, whichever is lying above and below this plus 2 standard deviation is your outlier, then what will happen? You are removing 2.27% of your data, which are normally distributed, which are in your normal distribution, and you are falsely identifying them as an outlier. So this risk is there. So instead of using this rule like 2 standard deviation or 1.5, the most the criteria, the recent criteria says that it should be 1.2. So 1.2 is the outlier leveling rule. 1.2 into what? Interquartile range. So if your if a particular value is lying above or below 1.2 into interquartile range, then you can safely identify the particular value as an outlier. So sorry, 2.2. Yeah. So these are the basic things. With Whisker plot, same thing here. 1.5 rule is here. Why? This is a picture taken from a classic book. That's why 1.5. But I have already told that this 1.5 is a misleading, because 50% out of the outlier may be actually included in the normal plot. So it is 1.2. But again, if you are so 2.2, again, if you are very much conservative, if you want to have you want to have any kind of problem, then you can take 3 also. So 3 is the extreme outlier rule. If a value is lying more than 3 into interquartile range, then you can safely remove that. Remove in the sense that you can safely label it as an outlier. Clear? So confidence interval, which I have already spoken, confidence interval is very important. Then what will happen if because everything was fine till your data was normal, what will happen if it becomes a non-parametric? So non-parametric is very important, because most of the statistician they don't apply, or most of the author they don't use any kind of non-parametric test. It may be because of a technical challenge, I don't know. But one problem with a non-parametric is non-parametric has a less power by itself. That is, for a given sample size, if you use non-parametric, then you may not be able to detect any statistical significant difference between 2 groups or so. Instead of using non-parametric, if you use parametric, then it will be statistically significant. That's why people may prefer parametric, because significant आ जाएगा उसमें, non-parametric में नहीं आएगा. Non-parametric require a larger sample size, but the problem is most of the parametric tests require assumption for normality. So these are the different tests. ये सब पूरा theoretical है. I am not going to speak into detail all these things, like independent t-test ka, if there is a problem in the what you call independent t-test, we have to use Mann-Whitney test, Peer t-test, then the Wilcoxon-Simon test. One way ANOVA is there, then Kruskal-Wallis test can be used, repeated measure ANOVA, then Fragment test can be used. Pearson correlation is for normality distributed. We can use Spearman correlation, or Kendall-Tau can also be a simple linear regression. See, linear regression, there is some doubt, which I will be practically doing linear regression. Then I will explain here. There are certain assumptions for linear and a multiple regression, which people doesn't follow at all. So let me check. So these are the different flowchart are there. Different flowchart which are if your this thing is normally distributed, then do this, then do that. So there are so many rules are there, so many things here. I just copy paste it. Why? Because I just want to show how the statistically statistics class will threaten you. I mean because everything is very simple. If you understand the basic technique, then you don't have to follow all this table and all this stuff and all these things. So practically you can do it. So let's stop our slide sharing, and I will share SPSS output directly. So let me share my SPSS, and I will, if there is any doubt by anyone, you can raise your voice, or you can directly speak to me. No problem. So let me see my SPSS. Okay. So this is the SPSS. SPSS. So this was one of my old paper, but I have just taken out. This is the ears and ear. So before going to SPSS, for those who are very new to SPSS, I would like to explain certain stuff. Why it is not going? Okay. Okay, take. So there is two view. There is data view and the variable view. So what I am presenting here is a data view. So how you want to enter the this value in a data view also you can do. You can directly export from the Excel also, or you can copy paste just like this. Suppose if I create a new one, this is a new one. Because I want to show from the very beginning. So when you open SPSS, it will look just like this, blank, everything blank. So how you are going to write in this? So you can directly copy paste also, you can write also. Suppose if I want to copy paste from the Excel, you open an Excel file and you copy paste, or you can import it. If you go to the file, then if you go to the data, then you can directly import from an Excel, so it will be directly there. And so this is a data view. Another one is the variable view. Variable view means this is the different variable. This variable view is nothing but a column. Different columns are there. Okay, so what you want to write in the column, you have to write in a variable view. Here, suppose I want to write S. Okay, so it will come like this. Okay, and here in the variable view you have different setting, like what is the type. It is a numeric, sometimes it is a string variable. If you put alphabetical, then it may become string. See, there are numeric, there are string variable, there are a lot of things. But the SPSS, since is a computer generated algorithm, it only identify a numerical value for computational purpose. So you have to, if your data is in string variable or something like that, then you have to convert into a numerical value. Then another is a width. Width means how much it can be increased up to 10, or I mean how much number you can write. This is the width, and this is the decimal point. If you increase the decimal point, then it will be increased. Like suppose if I write 1, or see, the number of the decimal point you can control from here, decimal. Okay. Level is nothing but, for example, SPSS doesn't, you cannot just continue, right? Like suppose weight in kg. I cannot write like this. See, I cannot write because it contains illegal character. Means if you want to write, then you have, if you want to write continue, there should not be any kind of gap. Suppose if I want to write weight in kg, instead of giving gap, I can give a underscore, and I can write like this. But here in the leveling view, I can explain everything like weight in kg, no problem. Okay, so in this way you can write. Another one, this is a missing value. Suppose if you collected a data, lots of data, and it happens that there are some missing value or something like that. So missing value, you can if there is no, if you have a missing value, then you can give a number to a particular missing value, which I will show when there is actually a missing value. And then another one is the measurement type of the data you have to write. Suppose S is a scalar data, so you have to write scale. And if it was a gender or something like that, then I can select nominal data or ordinal data. So let's go to this one. This is the already data fill. So you can see in the different column is height, weight, BMI, body fat, VO2 max. These are the different stuff. And here you can see that beautifully I have written that is S in, actually S in year, since SPSS doesn't recognize the what you call the space. So you can write like this, S in centimeter, or no problem. It is a numerical, so it is numerical. See, it is, there is string variable is there. So weight, I've given 10 and then decimal 0.1, and this is a leveling. Whatever you want to describe, you can write in the leveling, no problem. Okay. And there is no missing value, but let me create some missing value. See, you see here in the missing value, what I have done is I have recoded the missing value. Suppose this value is missing. Suppose, let's see, this is missing. Okay, 0. Suppose this value is missing. Then what will happen if I analyze it? then the SPSS, you have to tell the SPSS what you have to do with the missing value. Otherwise, your calculation will bring results which are different from what you expected. So if you want the SPSS to identify the missing value, you can write, instead of this one, you can write suppose some code. Some code maybe in some numerical value. Suppose I write 9999. Okay, then I write 9999 or another 9. That means I want the SPSS to recognize that whatever I have written, like 999, how many? 1, 2, 3, 4, 5. It is a missing value. Then what will I do? I will just go in a variable view and in the height, and then I will go to the missing value. Then I will type, see, discrete, because I have given a discrete number for missing values, and I can write 1, 2, 3, 4, 5. That means whatever my value is 1, 2, 3, 4, 5, there is 999, it will be identified as a missing value by the SPSS. As simple as it is. Okay. And if you have more than, you can also write range. Suppose a particular value is missing, ranging from 10 to 20 or something like that. You can easily write here also. So SPSS has all the option how you want to handle the missing value. Okay, so this is the handling of the missing value. Another one is a different, which I have already written. This is a scalar variable, so I have written scale. Another one is the S. S mein dekhiye, I have recoded the S. Suppose this is the, I can drag also in the S. See what have I done is I have recoded the S, just like what I have coded here. So let me remove it. Was it's not missing, so let me, okay, take it, let me copy paste it. No missing value, huh? Let's see. No problem. Okay, no problem. And let's remove the missing value. No problem. Okay. So suppose I want to, this is S in year 2030 to 24. This is continuous variable. This is a scalar data. I can convert this data into a into a what you call in ordinal data also, or not nominal, it can be converted into ordinal data. Suppose if I want to divide the age group into two categories, for example, equal to or less than 25 years or more than 25 years, I can easily do it. For that you have to use option of value here. In the value, if you click any value here, type, then it tells you what you have to tell SPSS what you want to do. Suppose I want to in the age group, I want to create two categories. So I will write here, and then I will write whatever I want to create. Suppose I want to create another variable here, and it is here, it should be 25 to 30. Let's say 25 to 30, 25 to 30 years. So it will be changed, the number 2 will be changed, and I will put a number 3, then it will be more than 30 years. Like this. If you add like this, then it will create the whole continuous data is. It can be divided into a 3 ordinal data. So because different statistical tests you can use by using an ordinal, like chi-square test, all these things. So in this way we can easily do it. Okay, clear? So this is the one. So this is the use of the value. So in this way I have created for age, let's put the age code to the near age, and for BMI also let's put to the BMI here, up to BMI. So here in age I have created different code, 1 2 3 4. And what does the 1 mean? If you want to see, then you have to just click this one, this icon. If you click this icon value, then it will be converted like this, because 1 for me means less than or equal to 25. So it is saying, and 2 means more than 25. So in this way you can easily code a particular value in the SPSS, because SPSS is a computer algorithm. You cannot talk directly. You have to use the computer language or simple basic coding language. So in this way you can easily code different parameter into different thing. Okay, so this is the way. Suppose if you want, and these are a different the different useful icon. So let's first begin with our concept that whether a particular value is normally distributed or not. Suppose I want to check age and this height and weight and BMI whether they are normally distributed or not. Then what will I do? I will just go in the analyze section, and there are so many things which you can do with SPSS. Basic thing which I require is I will go to the explore. Then explore what will happen, and this box will come up in the dependent variable. You can you can put what is height, weight, whatever you want to do. You just put. Suppose I want to see whether they are age, height, weight, BMI, whether they are normally distributed or not. Just put it here in statistics section. Outlier also, percentile also, because I want to know the outlier. Okay, and see the detail option of all this thing we can discuss in a further workshop, because it will require a lot of time and we don't have much time. So that's why I am only telling you the basic stuff. Then in the plot also you can see plot stem and leaf is there. If you want to see take no problem. Histogram is we require. Normality testing is there. In this way you can see, and then option is there. Option may there, see missing value. So that's why missing value is important. If you suppose if you have a missing value, then you have to click tell the SPSS whether you want to analyze exclude case list-wise or pair-wise. If the case is excluded list-wise, that means the whole the whole person, the whole value which has that missing value will be removed from the analysis. So that is the demerit for the list-wise. For pair-wise means the analysis of that particular, only that particular missing value will be removed from that particular analysis. That means you will have the your sample size will not be that much reduced. So that's why you have to tell the machine, the SPSS, whether you have a missing value or not. If you have a missing value, then you have to tell how you want to go ahead, whether you want to analyze using exclusion list-wise or pair-wise. Suppose we don't have any kind of the missing value, then if everything is clear, then you can just click OK. So let's wait for some time. SPSS is running. So this is the output window, and from this output window you can say that this is a case summary memory. The first table is a case summary memory, and from here you can see that there is no missing value because I have removed all the missing. If missing value was there, then there would be some writing should be there here. And if you keep on dragging here, then you can see that this is a description table. This ACE is there because I have I want to calculate the normality for tree, that is age, height, and weight. So that's why this table is there. Here you can see mean is there, standard error is there, and median, everything is there, medium. And you can see that this skewness is there, kurtosis is there. You will just remember what I said in the value in the slide which I projected. How much should be skewness, how much should be kurtosis for a particular value to be approximately normally distributed. By applying that rule, you can see. Another one is if you want to say, then because if you want to have the outlier also, I have already said that outlier, we have an outlier leveling rule. For calculation you need 75 percentile and 25 percentile. That's why this if we click the percentile, so you can for S you can say this is a 75 value and this is a 25, you minus 30.5 minus 22 will be your interquartile range. And if you add 2.2 into 2.2 into interquartile range plus 30.5, if some value is there more than that, then it will be your outlier. And how you are going to know that a particular value is outlier or not? Another SPSS I have already given a table where it shows that in the AS there is highest and lowest value. That means the highest value number one is a number of the subject, not the value. So the highest number is number 1. The case number 30. The case number 30 is having the highest value. Highest means it has the highest value, highest numerical value of S, that is 40.0. So whether it comes as an outlier or not, you have to decide depending upon the outlier leveling rule. SPSS doesn't do that. You have to manually calculate. Or if you want to do something, then I will tell you a trick by using that also. You can easily do it. And this is another one, normality test. Normality test in SPSS, there is only two normality tests they have given. That is KS test, there is Kolmogorov-Smirnov test, and Saphirovic test. These are the two important tests which the SPSS is given. But apart from these two tests, there are so many other tests, like those people who are using the prism, then they will be knowing different type of tests there. So which one to use? See, you can see that just see in the significance section. This seems to be significant. That means you don't want these two tests to be significant to have your data normally distributed. Okay, so this is important. So the most important thing which you have to remember is, if you want to go ahead for a normality test, the significant should not be there. But when there's a conflicting, suppose here significant is there, significant means star is there, there is no star. So which test you have to follow? In case of a larger sample size, you always go ahead with a Saphirovic test. Saphirovic test is more, it has a more power as compared to the Kolmogorov-Smirnov test. So Saphirovic test is there. But in case of doubt, you always have to follow the visual method, which we use to follow, like histogram, whether it is approximately normally bell-shaped or not. Histogram you can see, or this is the leaf and stem plot, or another important plot is the QQ plot or PP plot. QQ plot means quantile plot. That means this is a straight line, and all the dot lines should, if all the dot line follows in this straight line, that means your data is approximately normally distributed. Here it is a little bit deviating, but more or less it is following this line. In the same way, another plot is known as this should be the PP plot, QQ plot. So in the same way, this is also like that. The plot should be approximately equally distributed on both sides. If it is too much deviating from this line, then we can say that they are not, very much normality will be very much violated. Another one, this is the box and a whisker plot, which the SPSS has drawn for you. If you double click it, then this graph will become like that. Then the SPSS have already shown a particular value, that is value number 30. Your variable number 30 is lying outside this one, and from here to here, what we have said that it is 1.5. So that means it is approximately outlier. But the problem is SPSS doesn't have an inbuilt system which you tell you that an outlier is more than 2.2 or not, because the latest paper says that if it is more than or less than 2.2, it becomes an outlier. But SPSS doesn't have that option. It only has two options, that is 1.5 and another is a 3. If it was more than 3, then star will come instead of this 0, instead of this circle. So circle means 30 is little bit doubtful, but still we can include, because 1.5 we can include, not as an outlier. Okay, so in this way we can see. So these are the same thing for the other variable. So approximately what we have learned today for the normality curve is, number one, normality can be done by a visual method. Visual method means this one. Visual method means this is the what is the histogram. It should be approximately normally distributed, number one. Or number two, it should be PP plot or QQ plot. All the dots should be along the line. Okay, these are the known as the visual method for normality testing. Another is a statistical method. Statistical method, what we have already talked about, two type of tests. That is where it is. Yes, here. Two tests, that is known as the Saphirovic test and the KS test. And out of the two tests, if the sample size is more, then you always choose Saphirovic test, because Saphirovic test has a greater power as compared to the Kolmogorov-Smirnov test. And but there is limitation, because Kolmogorov KS as well as Saphirovic test both require larger sample size. If your sample size is too less, then what will happen? These two tests will tell you that your data is normally distributed, but actually your data is not normally distributed. So you cannot depend upon these two tests. So that's why for normality test, everything has to be there, and histogram, box and whisker plot, PPQ plot, QQ plot, all these things, and your decision should come from combining all these points. So this was my point for doing normality test. Now Another one is another important point for any kind of the normality. Suppose if you want to do a comparison between two groups, that is by using a t-test or by using a Mann-Whitney test. T-test is basically we use when you want to compare means. In the same way, if you want to compare the median or something like that, then you have to use, if your value is not normally distributed, then you have to use Mann-Whitney test. So how you are going to do normality testing for that? We can also do it like this. Suppose this is the objective view, output view. So we will go to R1 and let me see whether how I want two group. No? So suppose let me see whether I have group the BMI into how much group. I don't know. I don't remember. See, 1 to 5 groups are there. So we don't require. We require only two groups. This one a BMI 1, and this is what BMI code 3. Okay, I have coded the BMI. This is the BMI into two group in the same way as I have coded. So BMI, this is the BMI. This is a raw value of BMI, and raw value I have coded BMI into two group, group 1 and group 2. And what do you mean by group 1? Group 1 means it is equal to or less than 22.9, or group 2 means more than 23%. So if I want to compare between these two groups, then how can I go? Suppose I want to compare, A's. Suppose I want to compare A's group between these two BMI group, then I have to do normality testing separately for group 1 and group 2. In that case, we can also do in the same way. You just go to analyze, descriptive, explore. Same way, instead of everything you put it here, because I want to compare A's, then you put A's, or suppose VO2 max. I want to compare VO2 max. Okay. In the factor list, what you have to do is you want to compare in which group? BMI 3. BMI 3 is the one which code 3 is the one which contain of two group. Everything will be same, no problem. So you just click it here. Then what will happen? See, SPSS have done analysis depending upon the two group. Beautifully they have done. There is no missing value. There is no missing value, no problem. I can go ahead. So A's is divided depending upon two group of BMI, like this way. So kurtosis is there, skewness is there. So by using that, you can approximate, and everything will be in the same way. So let's go ahead directly with the test. See, you just go to Saphirovic test. Saphirovic test here, none is statistically significant. That means your data is approximately normally distributed. You can use t-test. Okay, so let me use t-test. So I want to compare VO2 max and AS between two BMI group. How I am going to do? You just go to analyze. Okay, you can go from here again. You can go to analyze. Compare means, because I want to compare independent t-test means they are these two groups are not dependent or time based. So I will use to independent t-test. Then what will happen? Whatever test you want to do, that is as here, you just put, and you just put VO2 max here, and you want to compare by which group? BMI. So BMI code 3 will go here, but you have to define, because SPSS doesn't know anything. It is just computer algorithm. You have to tell, just define group. What was the code which I used for BMI 1 and 2? You have to remember, I use 1 and 2. I use 1 and 2. Let me check again. If you have any kind of doubt, then just check it again. Yeah, this was the BMI 3. Yeah, 1 and 2. That's all. That means I was right. Here, compare means go to independent t-test. Again, as and VO2 max, you just put. Okay, where is, and then where is VMI? Just put it here, and BMI code, just put it here. You just define 1 and 2. That's all. Very easy. You just do it, and in the option, see, there was no missing value, because if you have missing value, then you have to pay attention to this. Since there was no missing value, no problem. So you just click it. Then SPSS will do. This is the independent t-test. Independent t-test. Independent t-test. The another name is the unpaired t-test. Okay. Unpaired t-test. This is the another name. So this is the one, and here N is 15 and 20. This is a mean and standard deviation, standard error of mean, SEM. People reported SEM, but they don't report the standard deviation. See, you can see standard deviation is larger than SEM. That's why people want to fool you. That's why the author just reported this one, because they want to show that their data is less dispersed. So this is a wrong practice. Another is that, so how you are going to interpret the independent t-test. That's very important. I have already told you that three important things is very important. Number one is sample size. Number two is normality testing. Another is the homogeneity of variance. So how you are going to, because normality of testing we have already done by using Saphirovic test and Kolmogorov Smirnov test and also the visual method. What will we do in case of the homogeneity variant? Then we will use a Levin's test. Levin's test is the name of the test which use homogeneity of the variance, whether our data is heterocadasticity or heterocadastic or homoscedastic. Here, for that you have to see this p-value. If your p-value here, if your p-value is, see, what is this? It is not significant. Then in that condition, that means your homogeneity of the variance is satisfied. That means you can use t-test. You cannot use t-test if your homogeneity of the variance is not satisfied. In that case, you have to do adjustment in the p-value for a t-test. So if this test becomes significant, then you have to use this p-value, this one, the second column. Otherwise, you have to pick this one. So from this, what I learned is VO2 max, there was significantly the difference between VO2 max between BMI, lesser BMI and larger BMI. This should be your conclusion. And from this, using by this, you can write your thesis project or result. Okay, you can increase the numerical value also, because p-value is never zero. P-value cannot be zero. Here you can see the 0.00150. Okay, if you increase the number, you can easily increase, no problem. So in this way you can. So this is the t-test. Okay, so this is t-test is very easy. And suppose if you want, if your result violate homogeneity of the variance or your sample size, see, homogeneity of the variance also another, most of the author use one term that is known as what do you call the robustness of a test. What do you mean by robustness of a test? Robustness means if the assumption of a particular test is less strict, then we said that a particular test is more robust. That means you can use that test in different situations. Okay, if assumption is very strict and you cannot you cannot violate that particular assumption, then you can say that a particular test is not robust. So the t-test is said to be a robust for especially lesser sample size. Because classically what we were told that for a larger sample size you should use jet test instead of t-test. But the problem of jet test is you have to know the standard deviation of the population or something like this. These are all theoretical stuff. So what is important is if your sample size is unequal, then your robustness of a particular test decreases. That means you cannot use this particular test just like that. The sample size has to be equal, number one. If it is not equal, then you have to check whether you can apply that test or not. Because most of the time, if the sample size is different, then your homogeneity variance may not be equal, because assumption of the homogeneity is very important. Clear? So in this way, you have to see. Suppose our data was not statistically significant, it was not normally distributed or assumption was violated, and we want to still compare by using non-parametric test, that is Mann-Whitney test. Then how I am going to do? You just do analyze and just go to the non-parametric section here. Independent sample test is there. You just click here. There are so many things you don't have to do. Independent sample says for one, non-parametric. There are two ways. You can either click here or you can go to the legacy dialog. I find legacy dialog to be a little bit easier. So I will click legacy the independent two tests because there are only two samples. So I will click here. And I was comparing AS and VO2 max here. And what I was comparing between the BMI, two groups of BMI, that is BMI code 3. And you have to still define 1 and 2. That's all. Simple, very simple. Then you can use different type of tests like this Mann-Whitney U test, Kolmogorov-Smirnov test. These are the name of the different tests. But for our purpose, I want to use Mann-Whitney test because Mann-Whitney test is the non-parametric version of the parametric t-test. Then in option exact also, there are so many things like asymptomatic also, Monte Carlo is there. So there are so many correction you can do, but most of the time this can be used, no problem. Option also, you can if you want descriptive, then you can check this box. If you want quartile value also, you can check this box. And if you have any missing value, then you have to click accordingly, because in our case we don't have any missing value. It doesn't matter whether you click here or you click here, doesn't matter. So I will just click OK, and here our non-parametric test is here. This is the Mann-Whitney test. Mann-Whitney test, Mann-Whitney U test. Okay, so this is the name of the test. Here you can see, and these are the descriptive, that is the minimum, maximum, minimum value, and the median is 26 for A's, and VO2 max it is 33.8. And interquartile range or quartile deviation, you can easily calculate. What is the quartile deviation? 75 minus 25 divided by 2 will be the quartile deviation. And this is the Mann-Whitney test. And Mann-Whitney test, the most important part which we have to see is the p-value. Where is the p-value? The p-value is here. This is the p-value, and this is the exact p-value. This is and for all practical purpose, we will use asymptomatic, that asymptomatic, that is significant two-tail t-test. I'm not going into one tail and two tail. Difference between one tail and two tail, these are all theoretical concept. This is you have to define in your proposal or in your from beginning itself. So assuming that two tail, what is two tail p-value? So I am assuming that see, you can see that there is statistically significant difference between the A's and VO2 between the lower and higher BMI group. This should be your conclusion. Clear? So this conclude our what you call Mann-Whitney and t-test. Sir, आगे क्या? Sir है? अगर sir नहीं है तो I can continue. So this is the basic step. Sir है? Okay, you can. Participant, please tell me if you have enough, then I can stop. Otherwise, statics, so we can continue again, and lots of tests are there. You can do it. So please let me know. Theoretical concept is there where I'm not able to see anything. Okay, chat. Okay, chat box. Okay, so participant, if you have if you want to continue, then I can write. How does Spss handle missing value when performing analysis of paired variable? Very difficult. See, this is an important question. One is asking that if you are doing ये क्या हो रहा है? ये काला काला कैसे आ रहा है? Okay, chat box. Okay. I didn't note it. How does Spss handle missing value when performing analysis of the paired variable? See, one value is present, another is not present. Then that is very difficult. So in case of if you are doing some randomized control trial or something like that, and if you have a missing value, then there are different approach for that, like intention to treatment. There are some different approach. So depending upon your approach, you have to go ahead, like whether you want to remove that particular value entirely from the the analysis, but it will create two problems. The first one is it will reduce the sample size. Another one is it will create a bias. So that's why people doesn't do it. Another way is if you have a pre-test value, then if you don't have a post-test value, then you have to you can write the pre-test value in the post-test also. That means there is no significant change. So this is another way. And there are in SPSS also, there are so many different methods for handling the missing value, like regression methods is there. There are so many different tests there. If we take up the class, then it will take entire 30-minute session. For regression, by using a regression, you can approximately create a particular value depending upon different types. But all these things are approximation. And statistics is nothing but a probability, approximation. So the best approach is it's depend upon you, whether you make sure that there is no missing value, number 1 point. If there is a missing value and it is pre and post, then if you don't want to reduce the sample size, then you can put the pre-test value in the post-test instead of using all the statistical method which the SPSS gives you. Okay, so this is one of the way. SPSS is cost effective. No, how poor socio? Yes, SPSS is yeah. Another question is Dr. Manish Parihar is asking SPSS where we get the slide or recording as lecture for future. Okay, you want to get what slide or recording? Slide. So I just make it recording. I can do it anytime. We are also recording. We will be providing, but depending upon permission which we seek from NAMS as well as our center head, if they permit, then we will be showing this slide. Otherwise, we can also plan for a detail, from theoretical as well as practical aspects, starting from the basic to the advanced. We can plan in the near future also. Another SPSS is cost effective. Yes, SPSS is a little bit costly. I know that for a poor student, they can request their institute to provide the subscription. Otherwise, you can always do analysis, basic analysis using Excel. Excel has an important, if you know how to do Excel in different statistical method, you can do in Excel also, no problem. Another version of a less technical version of SPSS, which you can do, is also a graph prism. Graph prism is very easy. Everything is written here. SPSS, you have to do a little bit. In graph prism, it is very easy. It can be done very easily. So in that way, you can do. And how much will be the sample size for any test? See, the sample size, I have told you, the sample size, there is no limit for sample size. The more it is always better. But central limit theorem, there was a central limit theorem. There was something known as central limit theorem in biostatics. It says that it should be more than 30 or 40 sizable sample size. But the problem is that central limit theory also doesn't say that if your sample size is 30, then it will be good. It doesn't say like that. It just give an approximate number. That's all. So there is no fixed criteria that this number is a good enough and this number. So sample size calculation is it's very important before doing any kind of research. You do sample size calculation. For sample size calculation, 2-3 things are required depending upon what type of analysis you are going to do. If you are going to do comparative means, then you have to use different formula. If you are going to do regression or correlation, this thing you are going to use a different formula. But the most important thing is you want to know the standard deviation of the population and all this thing, which you can easily get from a previous published paper, or you can approximate by doing a pilot study just before doing your main study. Can we use another question is there, so let me check. Yes. Can we use parametric when a variable known to normally lives in population, but the variable not normally when a particular when our purpose is projection. One question is there, can we use parametric test when the variable is known to be normally distributed in population? In population, known to be normally in population. The basic idea of statistics is you don't have to do anything in the population, because sometimes measuring, knowing exact value from the population is very difficult. The basic purpose of statistics is that's only you do analysis from the sample, but by understanding that the sample, is approximately representing the population, and whatever result you are getting in the sample, you just project. You want to project in the population. So normally, if a particular variable is normally distributed in the population, it is generally assumed that it is normally distributed in a sample as well, but it is not always so. The most important thing is, I've told you, that is you have to physically do testing, and by visual method as well as by statistical method, and then only you can go ahead with 100% surety. Because why to keep doubt? So instead of keeping doubt, it's always better to do go ahead. So shall we continue other tests, or shall we stop here? I think stop. Okay, okay. So I think I have taken too much time, and there are lots of other tests also. So we will be doing that later on. So we will, since it is 4:30 already, so I will be stopping it. Thank you very much. I would like to continue with my previous talk. Only 3 tests are remaining, and after that we will be ending the session. So it will be basic biostatistics using SPSS again. So I will be continuing with 2 important talks, and then we can good to go. Okay. So we have already talked about the t-test and the Mann-Whitney test and what are the important requirements. So let's continue. When the comparison is more than two groups, then what should we do? Parametrically, generally we use one-way ANOVA, or if the normality assumption is violated, then we can use crystal Wallace test. If a repeated measure is there for a two sample, we use pair t-test. Otherwise, or if non-parametric is there, we use Wilcoxon-Seinring test. And for more than two, we use repeated measure ANOVA or fragment test. So just we will try to see how it is, how we can do it. So let's see, let's search one where more than two is there. I think here, okay, here it is session is there, number 2. Yes, 1, 2, and 3. Yes, BMI code 2. So let's try to compare our VO2 max in BMI code 2, because it has a three groups, because we want what you call the comparison between three groups or more than two groups. For that same thing, you have to go to comparison of means independent. The one-way ANOVA is there. In the one-way ANOVA, suppose I want to compare age and VO2 max or something, BMI or something, whatever you want, you just put it here. And the factor should be your the groups. The grouping was BMI code 2, which I have coded. And in the contrast, or there's no need to write in the contrast. Post-hoc test depends upon different type. It is most important. In generally, one-way repeated ANOVA or repeated measure ANOVA or one-way ANOVA is simple to perform, but most of the people neglect the post-hoc test. There are different types of post-hoc tests, and each post-hoc test has its own, the features. The most important features what the SPSS has given is, if the equality of variance assumption is there, then all these tests you can do. Like you can do LSD or Bonferroni Correction or SIDEX, or if your equality of variance is not assumed, then Gam-Howell test, Dunnett test, these are the important tests which has option for you. So I don't require all this thing. So, and homogeneity of the variance is just like the homoscedasticity what we have checked. So I will check this one. And descriptive statistics also fixed in a random effect if you want, otherwise no need. And Wells test is something which I want to explain now. And there is a mean plot. Let's see. And if missing data is there, then you have to place, you have to analyze depending upon whether you remove it case by case or list wise. So let's press continue and see. This is the one-way ANOVA, and let's see how you can interpret. This is the descriptive statistics of this section. This is missing because the value was not present here. That's why it is missing. Then these are the important features for one-way ANOVA here. Significance was there. Before interpreting this one, you have to see the Wells test. There is the Levin's test. If the Levin's test is significant, then you cannot go ahead with one-way ANOVA. You have to use Wells test. There is robust test. One Wells test is because of some numerical value, the number is missing here. Otherwise, it would have been there. So the main point from here is, if the homogeneity of the variance is violated, then you cannot use one-way ANOVA. You can use, but the problem is it will not be reliable. For reliability, you have to go ahead and use Wells test. So Wells test is the one which we prefer if the homogeneity of the variance is violated in case of the one-way ANOVA. So in the same way, if you want to do, the non-parametric version of the one-way ANOVA, same thing. If you go to the non-parametric test, there are so many things. And for dependent, it is only 2. Here you have to write K dependent. K means more than 2. So by clicking this, you can do. Otherwise, you can also do by pressing here. That is independent sample test like this. Here in the the SPSS, you have to tell what you have to do. Suppose I want to do a customized test, because I want to tell the machine what I am going to do. So I will click here. Then I will go to the fill. Fill means what you want to do. Suppose I want to measure VO2 max, comparison of the VO2 max in VMI code 2. 2 means more than 2 group is there. So this is the one. Then in the setting, you have to tell what type of test you want to do. I want to do this one, what you call Kruskal-Wallis test. And after Kruskal-Wallis test, if there is a significant value, then I can click here what type of the post hoc test I want to do, whether I want to compare between different peers. So I can select here. So in this way, and then you just click. Users have to press run. So this is the non-parametric version of where is this? Yes, this is a non-parametric version of repeated measure ANOVA. That is a Kruskal-Wallis test with post hoc test here. So if you click here, double click here, then this is the box Whisker plot is there. If you want a little beautification, you can click here, double click here, and then you can do many things which we will be doing later on. So what is important is you have to see this value. If this value is significant, that is for less than 0.05, that means there is significant difference between any of the two groups, but you don't know which group there is significant. For that, you have to perform the what you call post hoc test. And where is the post hoc test? Here. Users have to click here. If you want to pairwise comparison, then everything is given in SPSS, which you can say that these are the adjusted significant as well as significant. The Bonferroni correction and all the post hoc correction for multiple comparison are generally done because in SPSS, the p-value has to be reduced because it cannot be 0.05 when comparison is more than 2 because of the multiplication rule of the probability theory where there is multiplication rule. Because of that, there is, otherwise the probability of making type 1 error will be high. So in order to reduce that, you have to do Bonferroni correction or a different type of the statistical correction, which have a different algorithm, what type of the post hoc test you have to use. So all this thing is there. So let's go, because we don't have much time. So let's go to the version here. Okay, why is this not playing? Okay, it is playing. Yes, that's right. So this was the one-way ANOVA, and multiple. If you want to measure effect of just like a PRT test, PRT test for pre and post, you can use PRT test. For if the group is more than if the timeline which you are measuring is more than 2, then you have to use repeated measure ANOVA, and for the non-parametric version of the repeated measure ANOVA is a fragment test. So suppose if you want to use the repeated measure ANOVA, and let's see, just I want to compare. Suppose this is a VO2 max. Suppose this, let me write, so that, because in the SPSS, the way you enter data is also very important. So suppose I want to do repeated measure ANOVA. So let me assume it is a VO2 max 1. Suppose at a time point 1, I have taken this value. So, okay, sorry, 1. Okay, so let me say this is the VO2 max 2. Okay, VO2 max 2, time point 2, and suppose this is the VO2 max time point 3. Okay, so accordingly I can write here also VO2 max time 1 and 2. Okay, everything is good to go. So let's put this, because we are focusing this, let's put this above here. Let's see. Okay, just drag it above. That's all. And to the data view. So let's go to this one. This is time 1, time 2, time 3. Suppose you want to compare what is the effect of particular treatment or something like that is going on, but we don't have the control group here. So time 1, time 2, time 2, what is the difference between there? So in that case, you have to use a repeated measure ANOVA, because everything is repeating. It is not independent of each other. They are dependent parameter. If you want to compare between 1 and 2, then you have to use PRT test, or if a non-parametric version is the Wilcoxon test. Same thing. Just go to here, comparison. But the problem is, if you go to compare, means there is no only PRT sample T test can be done. For repeated measure ANOVA, there is no option. for that one, you have to go to the general linear model. In the general linear model, there is option for univariate, multivariate, and a repeated measure. Since it is a repeated measure, I will click in a repeated measure. Since there are 3 points, so I can click 3. And since it's a time point, so I will write time. So there are 3 time. So I will add. So I have to define. I have to tell the SPSS what are the time points. So I will click in define. Then time point 1, 2, 3 is there. To time point 1 mein VO2 max 1 was there. Time point 2 mein VO2 max 2. Time point 3 VO2 max 3. So I can do comparison between this 1, 2, 3, 4. And then for plotting, if you want plot and all this thing, you can write, no problem, like just like that. Some SPSS will give you a plotting. If you want plot, then is your post hoc test is also important, but why it is not activated? Because there is another option for doing post hoc test here, just like is here. Since time point, so you just go here, you compare means post hoc test is here. So generally Bonferroni test we can do. You can do LSD also, CDAC also, no problem. But I prefer Bonferroni post hoc test for repeated measure type. But it depends upon the homogeneity of the variance, satisfaction, number of the sample size, the difference in the sample size of the different groups. So algorithm is there, but basically I'm choosing Bonferroni here. Then you can collect the descriptive and all this homogeneity. This is very important because it's violate. Then you have to you have to think some other things. Okay. Then effect size is also there. Observe is also there. So whatever value which you want, you can click. The most important is the homogeneity of the variant and descriptive. If you want descriptive, that's all. Then you just click p-value is 0.05. It is already set, so there is nothing to do. You just click everything okay. Then you go ahead with the linear model. So many output are there. You don't have to confuse, because if you know the basic theory, then everything becomes very simple. Okay, or so these are the 3 dependent variables. These are the mean and the standard deviation. If you want to say reduce the point value, you just double click the table, click here, you just click like this. Where is the table properties? Okay, okay, numerical value. I want to reduce the decimal point to 2. That's it. It has reduced. This is the sample size. So different points are there. Which one to use? The most important which you have to see is the Moseley's test of the sphericity. It's just like the test for the homogeneity, which we have seen in the Levin's test in case of the ANOVA. The most important is if you have violated this one, because see 3 things: normality, sample size, and homogeneity of the variance. Three things was very important. So suppose normality, everything is satisfied, but you have to satisfy the assumption for homogeneity also. So for that, Moseley test of the sphericity is there. Since p-value is more than 0.05, that means we satisfy the assumption. Then we can go ahead and click the sphericity assumption p-value here. The p-value, since we are measuring the time factor, you just go to time and this is the p-value. That means there are statistically significant difference between VO2 max, but we don't know where. For that, we have to use post hoc test. Suppose if this Moseley test of sphericity was violated, suppose if this p-value was less than 0.05, then what will you do? You have to see the epsilon value. If the epsilon value, there is one algorithm. If the epsilon value is less than 0.75 and all this thing is there, then you have to use different this thing. But the most important thing is if it is violated, then generally we go ahead with the green where is that? Yeah, here. Yes, this one, greenhouse gaser p-value is, this is what we generally prefer, depending upon epsilon value. Otherwise you can also collect the Winfeld, but for choosing the Winfeld and the greenhouser, you have to see the epsilon value which is given in the above table. Okay, to depending upon this thing, you can say you have to select whether you can go ahead with the greenhouser geyser or Winfeld. So this was our repeated measure ANOVA. And for post hoc tests, since I have already tick the post-hoc test Bonferroni correction. This is the SPSS which they have given pairwise comparison between time point 1 and 2. If the comparison was there, it is statistically significant. So everything was statistical significant. That means difference, if you compare between any of the two groups, then significance was there. Okay, so this is the repeated measure ANOVA, and in the repeated measure ANOVA, you can see this is the graphical method which they have seen. If you want to beautify it, you just double click it, everything will come out. And I just want it to be a little bit like this, so I will apply here. Safed dikh raha hai, it's good measurement, and these are the data point. If you click here, then you can write the show data level, so this numerical value will also be there. So you can see that there is a significant difference between any of the p value. If you want to write double star also, no problem, just click it here, put star, double star, because as p value was less than 0.001, so it will be double star, and this double star will be between every group because the post-hoc test was significant. It is comparison between this and this, and same thing it is also. You just click here, copy and paste, and same thing here you can put here also, no problem. So in this way, for your thesis or data, you can easily write here. So significant is there between this and this, between this and this. Another is between baseline and this also baseline, and the other value also significant was there, which we have seen. Okay, so in this way you just write between, and if you write with bar and all this, you can write. But for SPSS you need a little bit of handling is there. If you want to do in graph prism, then everything is very simple. Everything is written. If you want to change the color and all this thing, you can do easily. So this was repeated measure ANOVA. What about a fragment test? If you want to do the fragment test, what should we do? So very easy. So suppose this was any of the group, for the assumption the normality has to be satisfied in each group. If one of the group or any of the group doesn't satisfy the normality, then you have to do the non-parametric test. And non-parametric fragment test we have already seen. And how to do fragment test? Same thing, very simple. Just go to the non-parametric tile legacy dialog, and you can collect the, since it is more than 2, then you have to see the k dependent this thing. Then you have BHU marks 1, 2, 3. Just put it here. Then here Monte Carlo, no need, because normally we don't have to do statics descriptive. If you want quartile and all this thing, you just click. 3 things are there. We are not doing Kendall tau. We are not doing Kendall. We are not doing Cochrane Q. What we are doing is fragment test. Just click fragment test and just OK. And let's see. This is the parametric test, non-parametric test, and its name is fragment test. Okay. And this is the non-parametric version of your repeated measure ANOVA. These are the different mean and standard deviation which is given here. And then what is important, it is also statistical significant. If you want to do post-hoc test, very easy. You can do post-hoc test. You can do post-hoc test of two ways you can do. Another one is that you can either do Wilcoxon sign rank test between each of the group, and you correct the p-value by using Bonferroni. The important rule is Bonferroni. How you are going to do manually Bonferroni? You just take the p-value that is 0.05, divide it by number of comparison. If suppose there is 3 type of comparison, because 3 groups is there, so you divide 0.05 divided by 3, it will be, and that p-value you should take for having statistical significance. That means for anything to be statistically significant, that p-value will not be 0.05, it will be less than 0.05, that is 0.05 divided by n, when n is the number of the comparison. So in this way, you can easily do fragment test. So let's go to the last one, that is the regression analysis, regression and correlation. If you want to do correlation between 2 variables, suppose bivariate correlation, there are different type of correlation. Partial correlation is there, semi-partial correlation is there. In bivariate correlation, at least 2 variable will be there. And in partial correlation, we are controlling some other factor, some third cofactor will be there, which we want to control from both the variable. Then it is called partial correlation. Semi-partial correlation or part correlation is also there, which SPSS doesn't give here. For that, you have to use higher, R or stata or something like that. Or otherwise, if you want to use SPSS to know the semi-partial or part correlation, then you have to do the regression, multiple regression analysis. In the multiple regression analysis, it gives a particular column for semi-partial correlation. So for bivariate, you just click bivariate. Suppose I want to do VO2 max and AS or BMI. You just whatever you want, you just click. If it is normally distributed, then Pearson. Otherwise, it will be Spearman or Kendall-Tau. You can click any. Since my significance is 2-tailed, you just click flag, means if there is significant that is less than 0.05, then it will be a particular tick will be there. So we will just tick it and see other though there is no need cross product different covariance. We don't need all this thing. If a missing value is there, then you have to correct accordingly. Just click it. So it will give a correlation matrix. This is known as correlation matrix. Star is there. Double star means significant at 0.01. 0.01. Clear? So we can see that there is a negative correlation between VO2 max and AS and BMI. So in this way, correlation is easily you can do it. सबको mute करो. Just mute all the participants. Clear. So in this way we can do correlation. So correlation is very easy. Last one we will do regression. Regression, there are so many different type of regression. Linear regression, non-linear regression, logarithmic regression. There are so many types, but the most important, most commonly used regression is simple linear regression. And in the linear regression, it may be simple linear regression or multiple linear regression. If there is only one dependent and independent variable, then it will be simple linear regression. And if we have more one dependent will be always one dependent and so many independent, then it will be multiple linear regression. So let's see an example of a linear regression. Okay. ये कैसे हटाएगा? All please mute yourself. Then suppose this is a linear regression. Suppose I want to predict. Please mute all the participants. Suppose I want to calculate a simple linear regression between VO2 max and BMI. Let's see BMI. Okay. So there are certain assumptions for linear regression as well. You cannot just keep on doing. The normality assumption for multiple and linear regression is the independent variable doesn't have to be normally distributed at all. This is number 1 point. So it is a little bit robust in that case. So what should be the normally distributed? The residual should be normally distributed. The residual means the predicted value minus the actual value. The actual value, that is the difference between the predicted and actual value, will be your residual. So if that is residual is there, then that has to be normally distributed. And if the dependent variable normally distributed, well and good. And apart from the normal distributed, there are so many other assumptions, like homoscedasticity, autocorrelation. So there are different type of tests which which are there in order to test that. So this is a simple linear regression. You just put everything. This is the dependent variable. This is the independent. Since we are predicting VO2 max, based upon a BMI. So BMI will become our independent variable. And in the statistics, if you click here, then you can put, you can write everything. Darwin, the most important is Darwin-Watson is very important. Confidence interval is also very important. Covariance matrix, if you want, then you click. Otherwise, R-square change is we don't require. Is generally used when we use a hierarchical multiple regression. Description, you can part and partial correlation. This is C. Part and partial correlation. Partial correlation, there is column in SPSS, but part correlation is not there. Part correlation means semi-partial correlation is known as part correlation. Collinearity diagnosis also there. All these things are for multiple regression. For simple regression, we don't require all these things. But still, I'm clicking just because I just want to show you what are these things. Then this is also important. This is because this is one of the assumptions for the multiple regression. That is, if I draw a Z means Z score of a what you call residual. This is the RE Z resid. It should be Y-axis and Z predict. If I this graph should be normally distributed. That's why normality testing is there. So this is very important in case of multiple regression, especially. You just click everything and click like this. So this is a regression analysis. This is the mean and a standard deviation is given. Then you just go correlation is there. This is not so important here. For multiple regression is very important because there is one problem for auto correlation. The independent variables should not be very highly correlated with one another. That is one of the assumption for multiple regression. Then you go to this is the model, and you have to see the p-value which is given under ANOVA. If the p-value is significant, that means your model is statistically significant. If your p-value is not significant, you cannot go ahead further. Stop, khatam ho gaya yahan pe. So if it is significant, then you go to the R square. R square is the strength, that is predictability of the the model. Though this is here the R square is 0.442, that is 44.2%. So how we are going to interpret 44.2% in the variability of the dependent variable is explained by the independent variable. That is 44.2% in the variability of the VO2 max is explained by BMI. That means 100 minus 44.2 it is not explained by BMI. So there are so many the other factor. Darwin-Watson is generally used. It should be nearly 2. The approximate, that is 1.5 to 2. If it is in between that, it is good. So it is mostly useful for multiple regression in order to detect something known as autocorrelation. So this is a simple regression, and how you are going to construct the regression equation for that, you have to come to this one, that is coefficient. If you double click here, double click here, then this is the constant variable. So so your equation will be y means VO2 equal to 16.29, okay, 16.29, then minus 1.279 into BMI. So this will be your simple regression equation. And if you see the significant p-value, that means BMI is significant. That means BMI has a significant unique contribution to VO2 max. And you can see the zero order correlation. Zero order correlation is nothing but Pearson correlation. And this is the partial correlation and semi-partial correlation. And collinearity diagnosis, I will be explaining more in case of the multiple regression, because in case of the multiple regression, the problem of the one high correlation between among different independent variable has to be avoided. So this is detected by VIF, that is variant inflation factor, and tolerance. Ideally, VIF should be, in case of the multiple regression, we generally use BIF, that is variant inflation factor, to be less than 10, or tolerance should be very high, that is more than 0.2 or 0.1. This is what we have to say. So this is the concept for, these are the different thing. You don't have to go. These are the different assumption. That is, it is generally normally distributed here. You can see the graph. So normality of the normality of the residual is important, because if your residual is not normally distributed, you cannot go ahead with regression analysis. You cannot do like that. This same thing, PP plot, same thing. It should be all the dots should lie along this line. Then you can say that it is normally distributed. And this is the this is very important because depending upon this graph, there are statistical method also, like Bruce Pagan Coinker test is there. Unfortunately, SPSS doesn't provide that test. But here, visual method, you can see that there should not be any kind of pattern in this scattered plot. If you see a particular pattern, then heteroscedasticity is present. You cannot go ahead with regression analysis. For a regression analysis to do, homoscedasticity should be there. And for that, there should not be any kind of pattern. See, funding out is there. A little bit funding out is there. So any kind of the pattern should not be there. So this is important. So same thing, let's go ahead with the multiple regression. You go to regression, same thing, linear. Instead of the BMI and all this thing, uses S. You just put S. S, because I want to predict VO2 max by BMI and S. And any other is there? No need. Okay. Let's put height and see what happens. Okay. And this also exercise duration of let's see. And everything remains the same. Nothing to change. Collinearity diagnosis, I have to click here. Yes, do it. No problem. Then plot, everything remains the same. In saving, if you want to save certain things, like if you want to do further analysis, like the most important is a Mahalanobus and a Cook distance. That is generally we generally use that for detecting outlier and all that stuff. These are the different, like should be, you know, less than 1. If it is more than 1, then we have a problem. So this thing you can do, and if you want to do save the residual for further mathematical analysis, which Spss doesn't provide, then you can do this thing. So this is not required for now, and let's see. So this is the multiple regression. These are the dependent variable. These are the independent variable. And here correlation metric is there. I have told you that for correlation metrics, the intercorrelation among the independent variables should not be very high. There are different cutoff points. Like some authors says that it should be less than 0.6, or some say it should be less than 0.85 or something like that. But one you have to remember is there should not be high correlation between different one independent variable to another independent variable. Otherwise, your model will not work. This is important. Okay, then you go further, go down, and this is the correlation. Then everything is fine. Modern Darwin-Watson is a little bit less than 1.5. It should be nearly 2. That means 1.5 to 2.5 के range में होना चाहिए. It should be approximately. It is little bit less, so you can reject it also, but no problem. If it is very much deviating from 1.5, then you can straightforward reject your model. Otherwise, and these are the different point. The most important point which you have to remember in case of a multiple regression is you don't use R square. R square has a problem. R square has a problem means the more independent variable you are adding, R square will increase irrespective of you know, the predictive capacity of your model. That means you cannot depend upon blindly on R square in case of multiple regression. So R square has to be corrected depending upon a number of the independent variables. That's why we prefer adjusted R square in case of multiple regression. That means in case of the multiple regression, the probability, you know, the variability which is explained in VO2 max by all the independent variable is 87.5. It is very nice. 87.5 is बहुत अच्छा है. और देखिए R square means you know, 89.6. So adjusted R square is less than R square. Okay, and the ANOVA, it is significant. That means we can continue. We can use with this model. So we can go forward, and this is one of the most important table here. And these are the different independent variable which we have used. Let's see whether they satisfy or not. Number one, what we have see is the significant p-value. See. Only significant is these two things are significant. That means age and exercise duration. Other are not significant. What does that mean? What does that mean? Another criteria for a model is U1, most, if not all, independent variables should be statistical significant. So we cannot just use this model, because see, out of 1, 2, 3, 4, 5, out of 5, only 2 are significant. That means it is less than 50%. So it is not a very ideal model. So it should be statistically significant, and these are all higher and upper bound. These are all partial correlation and all this thing. And another important is the VIF. If the correlation between independent variable is very high, then you will identify, depending upon the VIF, that is variance inflation factor or tolerance. I have told you the VIF should be less than 10, and tolerance should be more than 0.2 or 0.1. So 0.2 or 0.1, everything is satisfied. So from this point of view, we can say that no problem. Multiple correlation, not much issue is there, but the problem is ये significant नहीं है. And how you are going to explain, interpret, how you are going to interpret in your result of a data multiple regression, कैसे करोगे? For that, you can see two factors. The first one is a standardized beta weight, देखिए standardized, or you can see the part correlation, which I say part correlation. Part correlation. Yeah, this is the R of the part correlation. So in order to get the R square, you have to square this. That is 0.05 into 0.05. Then you will get R square of the part correlation. And that R square will be the unique contribution by that independent variable over and above other independent variable. That means after controlling the effect of the other independent variable, how much is contributed by your independent variable of interest on the variability of the dependent variable, it can be explained by using the part R square. So SPSS doesn't give you R square. You have to calculate manually, or you have to use higher this thing R or stata or like that. So in this way, multiple regression is calculated, and these are all the different graph which I have already explained. So this is very important, and these are the basic, and out of this also there are so many other technique also which I can show, but the problem is there is limit of time, and we are coming nearer to our session. So I hope that my session was a little bit helpful. So I will be concluding my session, and if you have any kind of doubt, then you can ask me, no problem. We can demonstrate also. Graph also we can see, scattered graph very much. Let me draw one graph, because why should not I? Okay, just one graph, because this is my favorite topic, so I can go on all the other are saying just stop it. Okay, I will stop it, no problem. A scattered plot. Let's draw a scattered plot. Okay, chart builder. So let's draw a scattered plot. Scattered plot, because multiple regression is, people generally show multiple regression as, suppose it is a VO2 max and this is a BMI. So we will see. We will try to see whether what are the different point. Okay, no problem. Okay, good enough. Basic gallery is there. Okay, option. Okay, this is there. No problem. Then chart option is there, no problem. Okay. So in graph also, see, you can see the missing value has to be mentioned always, otherwise different will give different values. This is important. So let's see, this is the graph. So this is a scattered graph which I draw, the regression graph between VO2 max and VMI. So if you want to make this graph a little bit presentable manner, you can write this. And if you want to draw a regression curve, you click in one of the variable, then you just click the reference data, then this is your R square. This is the R square of this reference line. So this is the R square. And certain this what I am using is the SPSS 20 version. For higher version, there is one separate point where you can write the graph, just what we used to do in Excel, in case of Excel. Okay, and coloring also option is also there, timing also you can write. So this is the relationship between VO2 max and BMI. So we can say that there is a negatively correlation, and R square is 44.2%. You remember the 44.2% which we get in simple linear regression. So that is the graph. So in this way you can draw a beautiful graph by using SPSS. Okay, so this was the basic thing. So I will conclude my presentation, and let me take questions if there. Okay, can we perform significant difference between multiple treatment with single? Yes, absolutely. SPSS may see comparison can be done with different thing. Comparison post hoc, there are so many type of post hoc tests. Let me wait, let me say. Okay, so so this was in case of the repeated measure ANOVA. This was what if the Moseley test of the sphericity, if the Moseley test of sphericity then is violated, then you have to see the epsilon value. If it is more than 0.75, you take the Winfield. Otherwise, you take the Greenhauser Geyser p value. This was what I have explained. So there are different statistical post hoc tests are there. So depending upon the flow chart which you are following, if the n is equal, then you take all this otherwise Game-Havel and or Bonferroni correction is there. So the different post hoc tests are there, and each test has a characteristic advantage and disadvantage and all these things. One special post hoc test is there where you can compare every variable with only one group. That is also there. That is also available, and it is in SPSS. Okay, see, so by using SPSS, you can definitely use that one. Where is the chat box? Yeah, let me see. Okay, let me see the question. I forgot the question. So by using that, we can perform a difference between multiple group with one control. Yes, absolutely. With multiple treatment group, multiple treatment group, we can compare with a single group also. And for that, we have to use a particular post-hoc test where comparison is between one with multiple. Okay, so in this way we can use, and without having to make all the comparison. Yeah, absolutely. How to handle missing value correlation and regression? The missing value handling is a little bit difficult, because in case of the regression, if we use what you call pairwise pairwise exclusion, then your SPSS output will not be able to meaningful output may be there. Okay, ये हो रहा है. अच्छा, तो meaningful output may not be there. So for a regression analysis, it is always advised that you don't have any missing. If missing value is there, you try to put that missing value by using one of the statistical method like regression method or any other method which is already there. Otherwise, you can you have to remove that particular entire that subject from the analysis. So in there, although it will reduce the sample size, but in case of the regression, you cannot just do what you call the pairwise exclusion just like that. So in that way, there are certain disadvantages and all this thing. Without having, yes, how to handle missing value correlation regression? Same thing. Can we perform multiple regression analysis with discrete nominal independent? Yes. We can perform regression analysis with the nominal variable in case of dependent. If there is only two dichotomous, then we have to use logistic regression. That is known as logistic regression. So in case of the logistic regression, yes or no, or one or two, male or female, like that. So logistic regression is used when the dependent variable is the dichotomous. That is the only have two value, and the independent variable has to be scalar or continuous, and we can also increase multiple groups, multiple nominal multiple ordinal data also as a dependent variable, but we have to use different regression method for that. Can we do dimensional? Yes, dimensional reduction is very important. There are so many different techniques for dimensional reduction, like principal component analysis. Principal component analysis is one of the technique for dimension reduction. This is it is going to a little bit advanced. We can take over advanced session in later some workshop or something like that also. But there are so many different type of dimension reduction. That thing that is a principal component Pca is one of the example which can easily be done by using SPSS. I don't know whether I have that one. I can demonstrate it now, but no problem. We will demonstrate it later. So dimension reduction analysis can be done easily by using SPSS, like principal component, as well as other dimension reduction analysis are there. And dimension reduction, okay. Collinearity between independent multiple reduction. Okay. Dimension to high. Yes, absolutely. There is important. If there is a very high collinearity, there is multiple collinearity is there. Collinearity means if there is a very high correlation between dependent variable in multiple regression, we cannot go ahead, because VIF variance inflation factor will be it will be a problem you can get. So in that case, in order to reduce that, three steps are suggested. The first one step is just remove the the redundant variable, because the variance is, there is a shared variance. But if you don't want to remove it, then what will you do? You can do principal component PCA, and you can create a common component. And that common component you can put in the multiple regression as one of the independent variable. And the benefit of doing that is you reduce the what you call number of the variables, so your degree of freedom will be good, and there will not be much problem. But if you remove it, then instead of removing, then it's always better to do dimension reduction analysis for higher end. Otherwise, you can also do dimension reduction analysis. Very simple. You just center around the mean, or you just calculate and mean of all the variables which are having very high correlation to one another. So that is also one of the suggestion. And then how to handle missing correlation? Yeah, can you perform? Absolutely. Can we do dimension reduction? Absolutely. We should do it, and it is one of the options. Why did your correlation statistics pick up correlation of the why did your correlation pick up obvious correlation? Because this is a made up data. This is not an actual data. I just made up it for the purpose of this one. So this is not an actual one. It should height and BMI is calculated from height. So it must have, because I just made it up. So that may be one of the reasons. Please mention some book resources like video to SPSS. And okay, no problem. SPSS is not very difficult. It is very easy. Always start with basic biostatistics. Any book is there for market. Users purpose, users purchases, and users read it. The most important is application. If you don't apply, then you will forget. So you just do your thesis work or any research work, try to do it yourself. Don't depend upon biostatistician. You can take advice from him or her, but it's always better you do it yourself. So by doing it yourself, then you will learn, and you also try to do your friends data analysis, so that you may be learning different technique which may not be there in your thesis, because higher technique are not there in a simple MD level or degree level thesis. So you may be requiring help you from your different friends who are doing research in different field or PhD. Please SPSS mention sample size. More than sample can lead loss of resource. Sample size. More than required sample. See, sample size is always better to calculate your sample size before going ahead with your research. Depending upon your pilot study, or depending upon different published literature in the field, then you calculate the sample size. It's always better to do sample size so that your power of study remains high. The more sample size is good, but resources also required. So you have to adjust risk and benefit ratio should be there. Okay, I think this is enough, or these are a different thing or theoretical thing, and we don't have to go ahead with the all theoretical thing. And the most important is, just don't try to fit your data in whatever you want. You just don't. You should not play with the data, but statistics should be such that it should help you go ahead. So these are the different heterocadastries. Then how you are going to correct multicollinearity is there. Then you have to check what are the problem which is missing, because multicollinearity you can detect by VIF or tolerance. So thank you very much. This is the regression flow diagram. What are the steps which we have to do, and what are the different thing which you have to follow if you want to do a regression analysis. So I think one thing is also which I want to spoke, but the problem is limited time is there. In case of the randomized control trial, pre and post effect, there is some. This is a very common question by lots of researchers. Whether should I do gain score or ANCOVA? Acha, I have not shown ANCOVA. ANCOVA is nothing but you are just controlling a covariate. We can do easily, no problem. I think I received signal to stop. So gain score plus ANCOVA plus mix ANOVA. So these are the different type, where you can explain how you can go out. So I think it will be better if we take an entire statistical class with a workshop. It will be better instead of quickly doing like this. So thank you very much. So this is I hope those who have given today's exam must have done nicely. I have gave my exam, and I was lucky that I was among the few who scored top in this course. So thank you very much. So thank you very much. I think I must be able to address few of your doubt. So with this, we have come to the conclusion of our E-Symposium. And from the organizer side, I thank all the participants who have been with these 2 days with us and who share their view, and also all the resource person all the way from different eminent institutes